Could make it turn sideways. Oh well. Okay. So let's imagine now we've got this equation here, this standard form, and we want to change it to general form, or depending on your book, we've got center form and we want to change it to standard form, whichever they call it. But this being your center or standard form, this being your general or standard form, whichever way. So all we've got to do here is expand this one out, okay? Get rid of the fractions and expand it out. So the first thing I'm going to do here is I want to get rid of those fractions. So I'm going to multiply everything by the common denominator of 5, 7, and 1. What is the common denominator? Yeah, it's 35. So if I multiply 35 here, here, and here, 5 goes into 35 7 times. I'm left with 7 times x plus 3 squared plus 35 and 7 reduces down to 5. So I'm left with 5 times y minus 1 squared equals, and then 35 times the 1 equals actually 35. So now we're just going to FOIL out or use our specials to multiply out these two. So we're still going to have 7 times x squared plus 6x plus 9. Over here we're going to have 5 times y squared minus 2y plus 1, and that equals 35. And now we've got to distribute the 7 and the 5, right? So we're going to take the 7 here, 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 the 5 there, there, and there. So that's going to give us 7x squared plus 42x plus 63 plus, now we're into the y's, 5y squared minus 10y plus 5 equals 35. Now, the only last thing we've got to do is put it in the proper order of descending, exponential, and alphabetical order, and make it equal 0. So, in our final answer, we're going to have what? 7x squared, and then the 5y squared, the 42x, minus 10y, and then we have to remember to combine 63 and 5 and move the 35 over with subtraction. So a quick shortcut I did is I subtracted the 5 this way and got a nice cool 30, and so then I could subtract 30 from 63 and get plus 33. Finally equals 0, and there's our equation written out, expanded out. Now, notice it's the same equation I've got here. So let's go ahead and go the other direction now. So now what we're going to do is we're going to take this, and to get back to that, yep, you got it, we've got to complete the square. So how do we do that? Remember, what do? We first isolate the same variables. So I'm going to get the 7x squared plus the 42x together. Then I'm going to get the 5y squared minus 10y together. And then I want to get rid of the constant. Let's move that over by subtracting it over and get negative 33. Okay. Now, if you recall from completing the square, we've got to have a 1 coefficient here. So we have to divide the 7 out of this group. So when we do that, we end up with 7 times x squared plus, now 7 times what is 4? Yep, 7 times 6x would be 42x. And leave yourself a space there, because we're going to need to fill that in, remember, when we do the actual completing of the square. Here we're going to factor out the 5, so plus 5 times y squared, and take that out of negative 10y, and you're left with minus 2y, leave a space, equals negative 33. Now, at this point, we're ready to complete the square and factor at the same time. So if you recall, the way that I like to do this is we're going to write the factor, or prepare to complete the square for each of these here. So the multiplier comes down still, 7 comes down. Now we're going to have x plus or minus something squared, because that's going to be the factor of this thing. Here we're going to have the 5, and that's going to be times y plus or minus something squared. And then that's going to equal some number, right? So let's see. we're going to have to fill in blanks here and here, here and here, and then a total here after we've compensated twice for both of those things. Okay? So, what do we put in those blanks? If you recall, this is where we take half of b and square it. So take this coefficient and take half of it. So positive 6 would be positive 3. Square it right up there, plus 9. Now you've created a perfect square trinomial as well as its factor at the same time. Over here, half of negative 2 is negative 1. Square negative 1 and you get positive 1 right there. Okay? Again, another perfect square and its factor. So at this point, what we have to do is compensate for what we've done. And remember, we didn't put a 9 in here. We put 9 in a place being multiplied by this coefficient. We put in a value of 77 times 9, or 63. So I'm going to add 63 here. Over here, we put that 1 in a place being multiplied by the 5, so we put in a value of 5 times 1, or a value of 5. So I'm going to add 5 there. Last thing we got to do is combine those three numbers together right there. So negative 33 plus 63 would be 30, right? And then 30 plus 5, 35, like so. We're almost done, but we've got to realize, what does this always have to equal? When we've got our center form of an ellipse, it's always equal to 1. How do we make 35 equal to 1? Noticing these are both common factors of that number, right? Exactly. We're going to divide that 35 out of the equation from all parts. So divide by 35, divide this factor by 35, or this term by 35, divide this term by 35, and now we're going to reduce here and here, reduce here and here, reduce there. We're going to get our final answer now, where we see 7 goes into 7 once, 7 goes into 35 5 times is our denominator, under the x plus 3 squared. Over here, 5 goes into 5 once, 5 goes into 35 7 times is left over, the y minus 1 squared, and 35 over 35 is 1. And there we are, right back to our original equation. So, to do this, you're just multiplying it out and then putting it in proper order. To do this, you're completing the square to the x's and the y's at the same time, and then making sure it equals 1 in the end by dividing that out. Right on. Hope it helps. See you next round. Got one more to go.